I'm CK. Tonight we're doing the 5th module in the series from Erica Synths in their EDU series. Tonight we're doing their VCF voltage controlled filter. We'll see how that turns out. I'm sure that it'll be serviceable, and I'm also sure that the build manual that comes with this is very detailed, very rich in electronic detail, and something that I would recommend you download even if you don't get the kit. You can download it free from their website. I believe there are going to be 9 in this series, so we're more than halfway there. Let's put it together, see how it sounds. Hope you enjoy the video. Here's the box. As typical, a very simple box. From Erica Synths, I bought this from thonk.co.uk, where I buy many of my modules. And yes, I've looked at the user's manual, and it is once again, first it shows you how to breadboard stuff. It also describes what a filter does, and then all the details of the electronics that go into a filter and the result on your signal. Again, if you do nothing else, just download the user manual and read that, and you will get a lot of value. But let's see what's in the box that we're going to be putting together. Let's get the box ready for recycling. And we'll start as I usually do. Sorry, I forgot to put my visor on. I really got to clean this. It's been a couple of weeks. We'll start with the front panel and the circuit board, see what they look like. So here's the front panel. Cutoff frequency. Input level, I guess, resonance, CV1 level, and CV2 level. Then we've got input, CV1 and CV2, which are going to affect something. I don't know whether it's the cutoff, one's the cutoff and one's resonant or not. We'll find out as we go along. And then the output. So a relatively straightforward front panel. Now here's the circuit board. Let's look at the back first. So yeah, we've got pot, 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 jack, 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 jack. And as you can see, some very prominent test points along the way, if you want to plug into that. Then all these are external connections to various things. We're not going to be working with that, but you can if you choose to. Then on the circuit board itself, all the values for the components are marked on the board, so you could build it without the build guide if you want to. I'll be looking at the build guide just to make sure everything is going along interestingly and I don't miss anything particular. One interesting thing that they're showing on the build guide on the circuit board this time is they're showing the tolerances of the components they're using. 1% tolerance resistors, 2.5 tolerance caps, and so on. So that's an interesting addition. And of course, we have some of my least favorite things, stand-up resistors everywhere. I'll talk about that again because I always like, whenever I run into them, I like to talk about them and my personal objection to them. And we've got 2 TL074s, which are op amps. And the build guide, by the way, is dated June 10th, 2022, and I'm recording this on June 15th, 2022. So it's pretty fresh. The diode ladder filter, which is going to be in here, is this version 2. and that was October 2021, and then they incorporated it into this board, I assume. The board itself is very good. It's a surface mount type board, even though we're doing all through hole, and of course all the solder points are through hole plated, which is the best. Here's our mechanical bag, which I won't open yet. Typical pots. Looks like a nice knob. In fact, it's an excellent knob. Let me point out why I believe it's excellent. Besides good phenolic outside, it's got a metal insert and a nice big brass set screw. So that's very, very good. That's the best kind of knob. Now let's look at the, oh, and here's, I will complain about this again, because I ran into this today when I was setting up my EDU test rig. The red stripe is not very prominent. It's just little dots of red instead of a good solid stripe. And even out here in the workshop during the day, I had to look really closely to see where the red stripe was. Shouldn't have to do that, guys. Use different cords with nice distinct red stripes. Here's the electronics. Not a lot of electronics. The two op amps and their sockets. Bunch of diodes. Bunch of resistors. Some film caps. One trimmer. A couple of, I bet these are 104s. Yeah, these are 0.01 microfarad disc caps. They're typically used around the ICs to smooth the power, make sure that the chip is getting a steady stream of voltage. It takes out peaks and valleys in the voltage. And then a couple of 3 electrolytic caps, a couple of Zener diodes, and that's it. It's a pretty straightforward kit. So I'm going to get the soldering iron heated up, and we'll put this thing together. So now we'll look at what's in the electronics bag. Here's a whole bunch of diodes. These are going to make up the ladder filter he talks about. He goes in depth on using diodes as current control devices, not just binary on-off, but actual, because they're analog devices, they actually have a different current response than simply a binary on and off. And that's a very good read. I strongly recommend you take a look at that. Bunch of resistors. Here are our op amps and circuits. Here's a couple of shotkeys to control or condition the power. A nice trimmer. Some film caps. And a bunch of, I assume these are 104s. Yeah, these are 104s, 0.01 microfarad caps that are typically found around ICs, and you can see them here and here and here, and they, for lack of a term, they buffer the power to ensure that the chip is always getting a steady flow of power and it's not suffering from peaks and valleys as the power supply changes. So that's it. Looks pretty good, and I'm looking at the build guide now. It has a nice diagram, a nice circuit layout, which we call a schematic. I forgot the word for a minute, and we'll dive into it. Again, it's a pretty straightforward build, and we're going to start with all the resistors. We'll start over here, and I always like to check the resistors, particularly because they're saying they're 1%ers, and that's pretty tight tolerance. So these are coming in at 32 32.89, and the value is 33. So I think that's within 1%. Let me look at one on the other end. 32.92, so very close tolerance. Now the first thing when you're building a kit, if you're not familiar with the manufacturers, the first thing you take a look and say, how widely spaced are the holes? So when I'm doing this, do I want to bend the leads right up against the body, or do I have to give it a little space? And on this board, it looks like I'm going to need maybe a millimeter, not quite hard up against the body, but maybe a millimeter shoulder is what I'll call that. And we'll drop that in to see if I was correct. And yeah, that's just about perfect. So, not much else to say about resistors. So I'm going to put all the resistors on the board, and I will set the playback to fast motion with no commentary, because again, there's not much else to say about resistors. So enjoy resistor time. Okay, I'm going to stop resistor time just for a minute because we're working with stand-up resistors here. And just to be clear, they're used two reasons really. One is to reduce space, because if they're standing up they take less space on the board, and sometimes they come along as late additions. Somebody had to revise the design, they didn't want to relay out the board or change the size, so they put a resistor in stand up so it doesn't take much space. In this case, this is all designed. So you flip one lead all the way over like that, find where it goes, and you'll see that there's a circle here. That's where the body of the resistor goes, and then there's a short line connecting it to where the lead goes in. So that's how you can see. Okay, back to resistor time. So resistor time is over for this board, and I want to point out two things about the stand-up resistors, why I don't particularly care for them. One, a very rare but possible thing, and the other one just a little bit of inconvenience. First, it is possible, because I've done it, so this is going to be on the back. It's going to be on the back of your module. The power cord's hanging out the back like that. And when you reach around your rig or are working back in there moving cables, it is possible to bend these over, and there are circumstances, it's very rare, but it can happen, where you can short two leads against each other. That's just, it's extremely unlikely, but it is possible, and I don't particularly care for that. The other challenge is for you, the builder, is since they're stand-up, you don't have a nice rectangle where you can put the value. So if you're looking for a stand-up resistor and you can't figure out where it is, you have to expand your view. Like this resistor right here, its value is shown over here. These two resistors are in here, but their value is printed here, and there are these holes where the potentiometer legs are going to go in later that you might, if you haven't done this a lot, you might get confused and say, okay, the body goes in here and the other lead goes in here. Again, look for the little line on the circle showing you which direction it's going in. And if you can't find where the heck it is because the silk screening is offset. Just go to the build guide or a photograph or whatever and you should be able to find it. But that's it. Those are my two objections to stand-up resistors, and they're minor or unlikely, but I worry about things like that. Now we're going to do all the 4148 diodes. Now we're going to put the two IC sockets on. Make sure the notch on the socket matches the notch printed on the circuit board. And the way I like to do this is I rest the IC on my pinky finger behind the board. That's what's holding it against the board. And then I'll do one leg. Now let it cool, and I'll take a look, make sure it's all flat, and as you can see it's not. One side is up a little bit, so I'm just going to press on it with my index finger from the back, reheat that leg, and that settled it all back in. Another way you can do it is get yourself some locking tweezers. Pretty inexpensive on Amazon or eBay, and put your socket on, again making sure you've got the notch in the right direction. Then clamp it with the locking tweezers and it's not going anywhere. But the same rule still applies, and I'll show you here in a second. I'm going to solder one leg, and since the tweezers weren't applying exactly even pressure, this end is a little up. So again, I'll just press on that, reheat that pin, and it settles right onto the board. Now I'll go ahead and zap all these pins down. And yes, I do use every last millimeter of solder I can. I go through a lot of solder here in the workshop. Now let's see what they say to do next in the build guide. Okay, now we'll do the electrolytics. And again, you know, he did this in the other module I did. The photo here where he's showing how the capacitor goes in with the polarity correct, if you'll notice, this is not from this kit. This is from the EDU mix. So this picture, it does not go with this. It's simply showing where the positive lead and the negative lead and the mark on the circuit board is. So don't get confused by that. I would like them to take a picture of the product they're actually working on for folks who are starting out and might get confused because they can't see that particular layout on the board anywhere, and they're saying, well, I see what's going on, but it doesn't appear to be on the board I'm working on. You don't want to confuse people, and in an educational series product, you want to be even more sure. So these are 47 microfarad. Okay, two things left to solder on this side of the board. We have a trimmer, and the legs are a little ajar, askew, what do you mean ajar? And it's got a very clear indication here that here's where the screw goes. So that's nice. So we'll put that in. I don't know what that solder ball is doing there. It's not doing anybody any good. Just flick it off. And now the power supply, the power connector. And it's a keyed one. So we'll look here to make sure. The key on the socket will be facing outwards, and that's what we're doing here. But again, typically, and they have in the past, they'll put a red stripe indicator. But let me clip off these leads on the trimmer. Now we're done with this side, and we can start putting the controls on. First thing we'll do is we'll make sure the panel nuts are all off, and they are. And I'm not putting the ICs on until I'm all done with soldering. So these are all 100K pots, so we don't have to worry about it. Got to straighten up these legs a little bit. Oops. Got to get my orientation right. Little blue base ones go in these 4 spots, and the green one goes up as the cutoff filter. Now we'll set the jacks in place. And of course knock them out of place with my thumb. Now set the front panel on to make sure everything is aligned properly. And what I'm going to do is I'm going to solder one leg of this pot and one up. The jack's already twisted around as when I wasn't looking. There we go. And I'll solder one leg of this jack. Now I will, with everything held firmly together and remembering which one I did, I'll put a jack on here, a panel nut on this jack, finger tight, and then panel nut on this pot, again finger tight. It's all held together, everything's in place, everything moves well, and I can go ahead and solder all the pins. Now I'm going to do this pot first because it's the hardest, even though it's not really hard, but it's the hardest because these pins are right up against these foil caps and we don't want to bang our soldering iron against them, so we just treat it carefully. Okay, and I can turn the soldering iron off. Get the cat hair off. Now we'll put the two op amps in. And they're the same. Where's the notch? There's the notch. I don't have it bent in far enough. There we go. All the pins are in. I'm making sure this is fully seated. All the pins are in, fully seated. And there we are. It's not fully seated. Let me push that a little harder. There we go. Power cable. Now the hardest part for me, the knob, because I always get the index line wrong. I spin these panel nuts on the jacks. I'm only going to do these finger tight. I'm lying. I'm going to tighten them down. Oops. And there it is. Here's the front, the side, the back, other side, top, and bottom. Now we'll put it in the rack and hear how it sounds. And we're in the test rack. And this is, by the way, this is all the EDU modules I've built so far. And I took a half hour and built a new test rack to hold them so I didn't have to keep swapping things out in my other rack. And two other things we have I'm going to be using on the far right, the Blades of Ingenuity module from Frequency Central. I'm going to be using the LFO on that. And I'm going to be using the Befaco MIDI thing to send Note CV in as I need it to change values. So let me zoom in on the VCF and jerk the camera around a little bit and focus it manually so it doesn't shift when the hand gets in the way. And now we're ready to power it up. On my multi, let me bring up the oscilloscope. On my multi, I'll be watching the frequency response from that. Now we'll power it up and see if it blows up. Nope, first we're going to plug the power into the power supply. power supply from Frequency Central, one of their Routemasters. They just provide so much power I don't have to worry about anything. So let's see what this does. So there's no smoke. And I've got the sequencer from, it comes in this kit too, in this set too, and now, I'm sorry, I've got to see what I'm doing here. Okay, we've got the sequencer running, and as you can see on the scope, we're getting a little bit of stuff. Let me turn up the sound a little bit. I'm going to turn all the pulses on. So with cutoff all the way down, we're getting that. Now we take the cutoff up. Yeah, he mentioned this, the input level really matters here. You can see I'm all the way off on resonance. Let me change the envelope a little bit, add a little more attack and a little more release. So with no resonance, we open the filter up and it gets obviously more harmonics. So that's what we've got so far, and it sounds like a good filter. So I'm going to check the trimmer, and let me reread this just for a second. I'll read it out loud. Sorry for walking in front of the camera. Play around with the resonant control knob. Depending on your trimmer's initial setting, you might not get any resonance. If so, you'll have to experiment by dialing in different values on that trimmer. So the trimmer in the back will adjust our resonance. Let's see, even though we're getting some. Turn. Yep. So as you can hear, as I turn that trimmer, the resonance changes. So what I'm going to do is, there's no resonance now. And I'm going to go ahead and put it to about a little bit, maybe that many quarter turn or less up, and turn this trimmer out some. Because I'd like to get resonance a little earlier. My screwdriver keeps slipping out. Okay, so now I'm getting earlier resonance. And if I take it all the way up, it's going to distort. And that's probably too far out, because as you notice, the cutoff started cutting off way too early. So that's the way that works. Let me do one other thing. I'm going to take this Blades of Ingenuity LFO and put it into CV2, I think is what we're going to go into there. Let's see what we got now. We don't have anything now. I'm not sure what happened there. Let me pull this back out. Now I'm getting nothing anyway, so what did I do? Now I'm not getting anything out, and I don't really know why. There we go. And I'm adjusting the voltage for CV2 coming in to increase the amount that the LFO signal changes the resonance. So we've got both depth of resonance and how much the CV input from the LFO affects that. I'm going to try the LFO over here. And that affects the cutoff. I'll take that back out for now. So there you go. As you can see, it's a good low-pass resonant filter. It's going to take some tweaking to get the sound you want, because you want to tweak between, and I'll take the oscillator off the screen, the oscilloscope off the screen. You need to mess with input level and resonance and cutoff to get where you want to go. And again, the author of the guide describes the interaction with these very well. But it's a very serviceable VCF, and as you saw, a pretty straightforward build. So another good one from the EDU series, and again with a manual that makes everything pretty great. So that's it for this module. Hope you enjoyed the video.